So we're back again. The video errored. So no, in solving this, I couldn't get. So the next thing to do after getting the rate constant, we just use the same formula, but we have to use the rate to get the time. So in solving this, we just have to use the same formula, then inserting the rate constant. So after getting the rate constant, we multiply it to the same formula, which is and we're just going to change 12 to 8 because this is our final destination is the 8, because we're finding the determine the time needed to dry from solid from 30 to 8 pounds water per pound dry solid. So our final answer would be 7.747192131 hours. So we're going to put it in 4 decimal places. I mean, 2 decimal places in ano, is wherein the multiple choice is. So that is our final answer. 7.74 hours. So the next problem that we're going to solve, a wet material having a critical moisture content of 15% and an equilibrium moisture content of 3%, 3% took 6 hours to dry from 45% to 10% moisture. The time it took to dry from 8% to 55% moisture is, so our given is, so we have a critical moisture content where we're just going to 15% and an equilibrium moisture which is 3%. Then it took 6 hours. 6 hours it took to dry 45% to 10% moisture. So we are required to find also the time. This is the first problem. We are determined to find the time it took to dry from 8% to 5.5% moisture. So let's analyze. So we start at 45%. We start at 45%. Then critical point is 15%. So from 15%, 45% to 15% constant period, the 15% down, which is the falling rate period. The time given is 6 hours to reach 10% moisture. So in which is in the falling rate zone. Now look at what is being asked. The time from 8% to 5.5%. Since both 8% and 5% are below the critical moisture of 15%, the entire process happens inside the falling rate period only. So the formula that we're going to be using is just the same as the first problem. We only have to get the rate constant first, so that we're going to use it to find the time. So first is to establish our rate constant. So the same as so the formula the same as the first problem we're going to use. So T is equals to K x1 minus xc plus xe minus xe, multiply it by ln, and then xc minus xe is x2 ay, over x2 minus xe. So that is going to be the formula that we're going to be using. So in substituting this, t is 6 hours, which k, then multiply it to our xn. So our xn is going to use this one. So our xn is 0.45 minus our xc, which is the 0.15, which is the 15%, then plus 15, 0.15 minus 0.03. This is our equilibrium equilibrium moisture content, which is 0.03. Then multiplying it to our xc, which is the 0.415, then minus to 0.03 over 0. Our the 0.10 minus 0.303. So looking for K, we're just going to use shift solve. So the K that we get is 16.45 27.9946. So in using again, so we have to calculate the target interval. So from 8% to 5.5%, since we're going to use again the same formula on getting T, so that we can get the T, but just put in the K on the next formula. So T is equals to 16.45279946 minus our xc, which is 0.15, then minus to our equilibrium moisture content 0.03, then we are going to multiply it to our 0.08 and minus 0.03 over 0.055, then 0.0 minus 0.03. So our final time that we have is 1.36805.387 hours. So looking for our, I know that looking for our looking at our multiple choice, the best option of our answer is the 4 hours. So I'm just going to use the 4 hours in this. So that is our final answer for our problem number 2. So, and that completes our solution. To summarize what we learned, always check if you are above or below the critical moisture to know which formula to use. Then constant rate is linear and fast, which I mean, then the falling rate is logarithmic and slows down as you approach equilibrium. Thank you so much for listening, and I hope this explanation was very helpful. Goodbye.